Assalamualaikum madam. The topic of our presentation is graph. Let me introduce our group members. The first one is me. I'm Muhammad Akid, Shahid Baruddin, Ahmad Danish, Nazrin Siddiqui, and our leader is Abdul Rashid. First of all, I would like to start my presentation with the terms of graph. So, the first one, the graph consists of three terms such as the G is made of graph, V is vertices, E for edge, and Y is the function. So the graph are often used to record information about relationships or connection. It is because the connections are the most important information and not the pictures. So the next one, the example. So in a graph consists of a finite set of vertices, finite set of edges, and finite set of function. As you can see in graph V1 and V1, it is 1 and 2, and V2 is 4 and 3, the V3 is 1 and 3, V4 2 and 4, and lastly so the V5 is 1 and 2. So
for now, let's go for the terms for graph. Okay, first is the degree of a vertex. Degree of a vertex is number of edges connect to a vertex. For the second one is from a vertex to the same vertex. Any edge that connects from a vertex to the same vertex, such as loops, contributes to the degree of a vertex. Okay, then is the isolated vertex. Isolated vertex is a vertex with the degree of 0. And the next one is the adjacent vertex. Adjacent vertex is a pair of vertex that determine an edge or sharing the same edge. Okay. Okay, for the example, the number of degree for each vertex in this graph is 12, and the existence of the isolated vertex is 0, and any adjacent vertex in this graph is 5. Okay, now let's go on for the another terms for graph. And first one is the path. Path is a journey sequence from vertex V1 and travel through the edges to VK without using any edge twice. For the next one is the circuit. Circuit is a path that begins and ends at the same vertex, and also circuit can also be a cycle. For the third one, we can see the simple path. As for the simple path, is if no vertex appears more than once in the vertex sequence. For the example, identify path. Okay, for the path for this graph is ABED, because path is journey from V1 to VK without using any edge twice. Okay, for the simple path is ABC, because no vertex appear more than once in the vertex sequence. And the last one is the circuit one. As for the circuit is ABA. Circuit is a path that begins and ends at the same vertex. Okay, that's all from me. Now let's go on. Now I will pass the mic to Shahid.
Alright, now I will talk about type of graph. There is mainly two type of graph, which is connected and disconnected graph. For the connected, we could see all of the vertex are connected to each other through the edge. None of the vertex are left without connected, as in the example in the slide. Meanwhile, for the disconnected graph, there will be one or more vertex that are not connected to the main pieces, and for the connected part are known as the component of the graph. Next is the subgraph. As we can see the graph and the example, subgraph is a smaller graph taken from the original graph. For example, to find a subgraph is to choose any two or more connected edges from the graph and then separate them from the original graph.
Assalamualaikum, my name is Ahmad Dini. So today I'm going to talk about Euler path. Euler path should start and end at different vertices, and it must exactly two odd vertices. Next, Euler circuit should start and end at the same vertex, and it must be even vertices. This is the example of Euler path. It starts with E but ends with D, and it has two odd vertices. Next, we have example of Euler circuit. It starts with 1 and ends with 1, and it has even vertices. And this is the example of floor plan convert into graph. Thank you.
Present about Hampton path circuit. So what is the meaning of the Hampton path and the Hampton circuit? A Hampton path is a path that goes through every vertex exactly once, while the Hampton circuit is the Hamilton path that begins and ends at the same vertex. So as you can see, this is the example of the Hamilton path and the Hamilton circuit. As you notice, all edges are being used exactly once, and there is no way to determine a graph whether it has a Hamilton path or circuit. Let's do some exercise. So the vertex starts from E to D to B to A and to C. So from what have we learned, is this a Hamilton path? Yes, because they are only goes through vertex once. Is this a Hamilton circuit? No, because it doesn't end at the same vertex. Second exercise, the vertex starts from D to B to A to C and to D. So from what have we learned, is this the Hamilton path? Yes, because they only visit the vertex exactly once. Is this a Hamilton circuit? Also yes, because the vertex starts from D and ends with D.